Okay, I had a phone call. I had to start over. Scientific notation. Okay, we got a big number, a large number. In fact, we could probably even make it even bigger. We could add more zeros to the end, or we could add a number out the front, or two. Whatever, it's a really large number, and it's a number that if I was doing maths with it, I really wouldn't want to do that. So what we can do instead is we can change it so that it is easier to deal with. The way that we do that is we use scientific notation. Scientific notation. The other name for it is the standard form. Sometimes it's also referred to as that. Okay, so let's have a look about how we would actually turn this into standard notation. Well, there's a couple of things we need to know straight away. Firstly, we need to know where the decimal point is for this particular number right now. And for this number, it is right down here, right to the right-hand side of this very last zero. I'm just going to put that in so that you can see it there, even though when we write numbers, we don't normally have that last decimal place shown. The other important thing is we need to know what is the first number in our big long number. The first number is right up here. It's a 1. What I want to do is I want to shift that decimal point from where it is right now, and I want to shift it all the way up so that it is to the right of that first number. So what I do is I normally use these little loopy jumps that I'm going to draw in here. So I'm going to go 1, 2, 3. We're trying to count how many steps we have to move the decimal point. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I want to move the decimal point to that spot right there. It is 13 spaces or 13 jumps away from where my decimal point is right now. So let me write down what that number would look like once I shifted the decimal point. It would be 1.56, because these are the numbers that are significant, right? We have to remember we have to look for the significant numbers, which is any numbers that aren't zero. Some zeros can be significant if there is another number after it, right? If this, for example, was another 6 here, instead of just being a 0, then I'd have to keep the 0 and the 6, which I'll do just because I drew it in there. So I would then need to multiply that by 10 to the power of the number of little jumps that I made. And I remembered that I made 13 jumps. So if you were doing maths, would you like to write this great big long number every time, or would you write this shorter one? Well, if you're lazy like me, you'd want to write this shorter one down, because the shorter one is much easier to deal with. Okay, so that's writing scientific notation with a really big number. What happens if there's a really little number? So let's say we have a really little number, 0.000000000567. That'll do. There's my very small number, and let me just sign off. I'll draw a line across here so you don't think that it's part of the same thing. Okay, once again, I do a very similar process. I ask myself, where's my decimal point right now? And in this instance, the decimal point is right here. I have my decimal point already shown. I don't need to go looking for it. Once again, I need to find another number. I have to actually go down until I find my first significant figure. My first significant figure is this 5. So I want to shift my number so that the decimal point happens to be after that 5 right here. Okay, so once again, I'm going to draw my little bouncy way down to where that decimal point is going to be and count as I go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To get to there took me 10 little jumps. Okay, so that's fine. 10 little jumps is okay. I'm now going to rewrite my number, and I'm going to write it based on where that decimal point is now. So it will be 5.67 because I have 3 significant figures. I have to have them all. I then multiply it by 10 and I write down how many jumps I made. It was 10 to the power of 10. Now there's one last thing I have to do and I can't forget, otherwise it makes my answer very wrong, is if the number that I started with is less than 1, my index has to be a negative number. So you'll notice that right down here, I actually have put it's a negative 10. I did 10 jumps from here down to here, but because the number I started with was smaller than 1, it's going to be negative 10. That will be the index there. And that really is how you change numbers, very big numbers and very small numbers, into scientific notation.